All right, students, we're looking at the graphing worksheet. Thank you for looking at the same thing as me. I handed you 3 worksheets. This is where we want to begin. We are looking at expediently, which has the word speed in it, graphing functions. So as you look at this, you're noticing, oh, these first 3 have an exponent of 2. These ones are quadratic. The next 3 are absolute value, and then the bottom 3 are meant to be cubic. Please change the last problem on the page to an exponent of 3. We're also going to remind ourselves of the AHK form just by writing it up at the top. It's y equals a parentheses x minus h operation plus k. And our first step is going to be identifying the HK. So remember, in the parentheses, we switch the sign because it's a minus in the formula. So the first one is 4,1. The second one is 1,5. The third one is -6,2. Please finish and find all of them on the page. You can just do the front for now. And I'm going to stop when Sophia, who I can see easily, has finished finding all of her HKs. Should I say zoiks? All right, cool. So students, we found our HK. That's great. What I'm going to do now is I'm going to plot my HK for the first function at 4 for x, 1 for y. It's a little bit challenging for me right here. That's good. I am also going to generate my parent function. So in case we forgot, since the operation is squaring, I create my x values, -2, -1, 0, 1, and 2, just by plugging those typical values in. And then the y value comes from squaring those. -2 squared is 4. -1 squared is 1. 0, 1, and 4. Your writing might be a little bit better than mine. And the next thing we're going to do is we're going to use our imagination. We're going to practice pretending. Okay, so just to practice, I'm going to pretend to put on an apron. Oh, here's my apron. I'm pretending to put it over my head. Oh, now I am tying it. I am ready to cook some food. What are you going to pretend to do? Do some pretend right now. Perhaps you'd like to wear a tiara. Pretend, there you go, pretending to leave. Great. Practice pretending. You got it? You pretended? Feeling more playful? Good. So we're going to pretend that the ordered pair 4,1, this ordered pair that we've already plotted, we're pretending it's the origin. I'm pretending. It's not the origin, but I'm going to act as if it were. Now I'm going to plot my parent function. So if I'm pretending that this is the origin, you can see my little tiny pencil here. I move to -2 for x, which is just -2 right here. And then I'm going to count up 4. 1, 2, 3, 4. To plot the next ordered pair, right here, I'm going to plot that whole parent t-table. So the next ordered pair is -1, 1. So pretending that 4,1 is the origin, -1 is left 1 unit and then up 1 unit. I've already plot 0, 0. Next, I'm going to plot 1, 1. So that's to the right 1 and then up 1, to the right 1 and then up 1. And then finally, I'm going to plot 2, 4. So I'm going to go to the right 2 units and then up 1, 2, 3, 4 units. So you're seeing that parabolic shape is still there, but I've plotted it without making the x plus h ay plus k table using pretending. So let's connect the dots. That looks beautiful. So this is what we're going to do every time on this page. So for the next problem, I don't need to recreate the parent t table. I've already written it down once. All I need to do is start by plotting 1, 5, 1 for x, 5 for y. And then pretending that that's the origin, I need to move to the left 2 units and up 4 units. Okay. Then I move to the left 1 and up 1. I don't need to plot 0, 0. I've already plotted it. I move to the right 1 and up 1. And then I move to the right 2 and up 4. Try the same strategy for the third problem. Oh man. Okay, I didn't know the same thing. Oh, you guys are doing great. You're doing great. Oh, some of you are so advanced and have done the whole page. Incredible. Okay, so looking at this third one here, -6 for x, 2 for y. I start there. I go to the left 2 and up 4. 1, 2, 3, 4. I move to the left 1, up 1, right 1, up 1, right 2, up 4. The point is that it would go faster than making the x plus h, ay plus k table. If you're not comfortable taking the shortcut, don't. Ellie.
Question for the one below, like the top one, it has the absolute value.
Yes, so absolute value is different shape. So you have a different parent table and we have a different strategy. So you're ahead. Okay, questions on the first 3? First 3, okay, cool. I'm gonna scroll down to look at the absolute value functions. So looking at these, we see our HK. And then what's also important to note is that this is absolute value, like Ellie mentioned. Absolute value is made up of 2 lines. This one makes the V shape. So all of these have the same A value. The whole front page has the A value of 1. In absolute value, the A value is the slope. So I start at -5, -7. These ones were taught without a parent table. So we don't graph them with the parent table. I go to -5 for X, -7 for Y. And then I count for the slope. The slope is positive, so I expect the arrows to point up. When the slope is negative, the arrows point down. I count up 1 and over 1 until I reach the X axis. I reach the X axis at 2. Then I go back to where I started at -5, 7, and I count up 1 and over 1 the other direction. And I don't end up meeting the X axis on this side. It goes off the grid. But typically we want to find X intercepts by graphing if we can, because it's so much easier than doing the calculations. And yeah, it's way easier to draw on paper. It's just the computer screen that makes my lines look so wiggly. So you can do the same thing for those other 2 if you haven't yet already. You want to make sure that it makes the V shape. Serenity, I know you already finished this, right? And Kira also. So you're cool to just relax. Let me know if you guys have a question. I know some of you guys have questions. Okay, cool. So now on the last set, you guys are doing great with this. The last set has the exponent of 3, and that means that it has a different parent function. This one is the cubic function. And so this one, we will want to create that parent T table. Before I do that, I want to mention the HK, since you guys already found them. There are no parentheses in this equation, meaning that the H value is the number 0. This is 0,7. Is that what you guys found? Very good. For the next one, there's only numbers in the parentheses. Again, we switch the signs. This one is at -5, 0. So on your IXL practice, which you'll do in a few more minutes, there are a lot of problems that just have one transformation, meaning just just H or just K. And then some of them will just have A. Nathan.
Why is the last one positive?
Okay, good question. So on this one here, the first one, it says X to the 3rd power. So the number that's being taken to the operation, the power, is the X value, and that includes the H. X and H, right, they go together. H is an X value. So because there's nothing there being cubed, that tells me that the H value is 0. The K value never changes sign. It's just added afterwards. So 0 plus 7 stays 7. Whereas inside the parentheses, we're usually looking to make 0 the answer. So the number that makes 0 inside there is -5. So the number that makes 0 inside the next problem is -4. But the 4 on the outside does not change. That stays a 4. All right, so for these ones, our parent t table, we start with -2, -1, 0, 1, and 2. The operation is cubing, so we do x to the third power. That will be -8, -1, 0, 1, and 8. You can always generate this if you forget. You can use a calculator, give it the third power. So once I have that parent table written down once, now I'm going to use it 3 times. I said to change this exponent to a 3. So I start at 0, 7. And then I go left 2 units and down 8. Left 2, down 8. Left 1, down 1. Up 1, over 1. And then I would go up 8 on the next. And yeah, I can see that that's off the grid. So I'm just going to draw my arrow facing up down there because I know that it's off the graph. This is the vertical snake shape. Try the same thing on the last 2 on this page if you haven't yet already, making that same shape. Okay, so my graphs, you can see that they got kind of moved around. But overall, your shape here should be on the x-axis where it has that point of inflection. And this one should have the point of inflection at -4, 4. Should look similar to this. Every single one of these on the first page has the a value of what? They all have the same a value of 1. So the work was just using the parent function, the parent shape. When we look at the back side, you're going to notice that the a value is numbers other than 1. So in this case, we're going to have a different strategy. It's going to be kind of the same, but different, which is good. So starting with the first one, what's our a value here? 2. Good. We see that the exponent is 2. So this is quadratic. Let's make our parent t table. Make it like this. Aha. So I have my x value, -2, -1, 0, 1, and 2. Then I square those to obtain my y value. 4, 1, 0, 1, 4. That's right. You guys can hear Dre came on. We are going to do AY. The A value this time is 2, 2y. So I'm going to multiply the y values by 2. Y is a multiplication. A is a multiplication. So that's what we're really going to see here. So 2 times 4 is 8. 2 times 1 is 2. 2 times 0, still 0. 2 times 1 is 2. And 2 times 4 is 8. Question?
How did you get column Y?
I squared them because the exponent was 2.
Wouldn't y be 8 then?
2 squared is 4. What? -2 when I square it makes +4. -1 when I square it. Squaring, remember, means timesing by its.
9 in the y then.
That's a 4.
Oh.
Does not look like a 4. Okay. So now that we've created this Y column with the AY, what we want to do is a gentle slash. Jordan. I just told you to do that. So that's the new thing that we're doing on this side. What we do is we take the Y values and we times them by the A value, which this time was 2. So we did 2 times 4, 2 times 1, 2 times 0, 2 times 1, and 2 times 4. So we're just creating the A table. Hopefully you're seeing that right here. This is where the A value shows up. When I'm 1 unit away, I go up 2 units, which is really nice. When the A value is a whole number, it's really easy to plot it because it's just 1 unit away, go up however many units it says for A. Or if A is negative, go down that many units. So I'm going to, just as I did before, start at 4, 1, 4, 1. I'm pretending that 4, 1 is the what? Origin. And now I'm going to go 2 units to the left, and then I'm going to go up 8 units this time because the A value is 2. So 2 units to the left, up 8 units. I go 1 unit to the left, 1 unit, and then I go up 2. I'm still at 0, 0. That's my 4, 1. Then I'm going to go 1 unit to the right and up 2. And then I go 2 units to the right and again up 8 to create that symmetry. It's going to be a more narrow graph than before. The A value has the effect of stretching.
Wait, how are you graphing it with 3 numbers?
I'm graphing the 5 ordered pairs that I just created. -2, 8, -1, 2, 0, 0, 1, 2. Yes, I slash this out.
Oh.
I don't use it anymore. I think it, yes, great, you did your service. It helped me create the AY table. Now I connect the dots. Okay, cool. So that one was fun. When we have an A value that's a whole number, we want to remember that when we move over 1 unit, we go up or down A units, which is really nice. Looking at our next equation, the A value is not a whole number. The A value is a fraction. Looking at the Y values, 4, 1, 0, 1, 4. None of those numbers are divisible by 3. The fraction 1/3 means divide by 3. None of those are going to work. So we need to adjust our parent t table. We need to plug in an additional number. I know that my AY is going to be 1/3 Y. So which number will I want to plug in so that it will divide evenly with 3? 3 is correct. Let's do it. So I'm going to plug in -3. And I'm not going to plug in -2. I'll also plug in -1, 0, 1, and then +3. So I've changed up my parent t table, but just a little bit. I changed in the input values. I can create the Y values because the operation is squaring. What's -3 squared? 9. -1 squared is still 1. 0 squared is 0. 1 squared is 1. +3 squared is again 9. So we can plug in any numbers we want to our parent t table to make whole number values. Question here, Maverick.
Oh, no question.
All right. That sounds like there might be a question. What are you curious about?
I wasn't that curious.
All right. So now I'm thinking of divide by 3. What is 9 divided by 3? Perfect. It's 3. Then 1 divided by 3, I'm going to write that as the decimal. What's 1 divided by 3? A third, which is 0.3 repeating. That's going to be really hard to graph. Not easy there. 0 divided by 3 is still 0. And then let's use the symmetry. 0.3 repeating, and then 3. We finished our calculations. Now that we finished these calculations, we want to gently cross off the y values that we used up. We've used them up. We don't need them anymore. Now I'm going to plot my HK 1, 5. I'm going to pretend that 1, 5 is the origin, and I'm going to move 3 units to the left and then up 3 units. 1, 2, 3, 1, 2, 3. If I move 1 unit to the left, I move up a third of a unit. That's really difficult to graph. If I move 1 unit to the right, I move up 0.3, which is not even 0.5, right? Just about there. And then when I move 3 units to the right, 1, 2, 3, I move up 1, 2, 3. So it's really my job. I can skip those decimal units if I remember to graph this to make a U-shaped curve, not a V. This is meant to be a U-shaped curve. So make it look like a U when you connect the dots. Oh, mine looks so messy because of all those counting dots. Very cool. Okay, questions on this? All right, let's do the next one. So the next one has a decimal, -0.4. It's really important that we know what decimal fraction is equivalent to that. So what fraction is the same as 0.4? 2/5 is correct. So now that I know that that's -2/5, that's going to help me identify the same way how I need to change my parent function. So last time I had the denominator of 3, so I plugged in 3 and -3. This time I have the denominator of 5, so I'm going to plug in 5 and -5. That makes sense, right? Just whatever number is there, that's the number we need to plug in. So let's do it. I'm making just my A table. I need to do X and Y, and then I'll do the AY. Katie. -2/5 is the same as 0.4, but it's written in a way that's going to help me to know which number I need to plug in for X. So my X values, again, I'm replacing the 2 with 5. -5, -1, 0, 1, and 5. I square those to generate my Y values. 5 squared is 25. -1 squared is 1, 0, 1, and 25. Now I do the work of multiplying and by this fraction. So what I'm actually going to do is divide by 5 and then multiply by -2. So I can do it in my head. So 25 divided by 5 is 5. 5 times 2 is 10. And since it's negative, -10. I'm doing 1 times, it's -2/5 is the same as 0.4. So I'm just going to write -0.4. It's easier for me to graph decimals than fractions. Still 0, still negative 0.4, and then still negative 10. This is my AY side. So now that I've calculated these values, slash out the Y so I don't get confused. Gentle slash. Thank you for your help. I don't need you anymore. And then I'm going to plot negative 6, 2. Pretend that's the origin. When I try moving left 5 units, I am at negative 11. So I'm just going to kind of fudge a little bit over there. Here's negative 11 approximately. I'm going to go down 10 units. So I was positive 2 minus 10 is negative 8. When I move 1 unit to the left, I just go down like almost half. I do the same thing on the other side. I make sure it looks symmetrical, and then I want to plot this as a U-shaped curve. Oh, I missed. Missed again. Isn't that nice? Okay, so what's important here is that you know how to find the whole number solution, because in your IXL practice, that's what you're going to need to do. Let's do the absolute value graphs real quick. Make sure that you got those ones too. Now, absolute value does not require making a table. Absolute value is 2 lines. So in this one, the slope is negative 1. If the slope is negative, which way are the arrows going to face? Down is correct. So starting at negative 5, negative 7, we just go down 1 over 1 in both directions. That should be pretty quick. The slope is just negative 1. For the next function, I find the HK 6, negative 8. And the M is equal to 3, which is up 3 and over 1. Up 3 and over 1. So my x-intercept is not a whole number. I go up 3 and over 1 the other direction to make it look like a V. And I will find the y-intercept if I can. Beautiful. Finally, 2/3 means I go up 2 and then I go over 3. So starting at 1, negative 3, up 2 and over 3. And then beginning again at 1, negative 3, up 2 and over 3 the other way. Okay, so great. We don't need to do the last few. That's if you want to. It's now time for us to switch into our computer. We want to correct our quiz, finish our quiz, whatever it might be from last week. The corrections are due tomorrow at 11 p.m. And then you want to start on your IXL practice. I have IXL for absolute value and IXL for quadratics. Kira. So then this is your time. Take the quiz. Yes, it is. If you were absent last week and you need me to go over this stuff with you, I'm going to do that right now. Just a moment.